Welcome to Study Loop.
Work done by the force exerted on a proton is given by W is equal to integral x1 y1 to x2 y2, force which is minus 12x squared in I direction, and our dr is dxi plus dyj. From here, then the integral we get here is minus 4x3 from x1 to x2 here. Substituting those values, we get here work to be 4x1 3 minus 4x2 3. When a proton moves from a point, for part A, from a point 1, which is 0.10 meter, to point 2, which is 0.10 meter to 0.40 meter, the work done on the proton is then given by substituting these values. Work done will be 4 times 0.1 cube minus 4 times 0.1 cube. This is equal to 0. So W1 is 0. When the proton moves from a point, for part B, from point 0.10 meter to P2 point, which is 0.30 to 0, the work done on a proton is given by the same equation, 4 times 0.1 cube minus 4 times 0.3 cube. This gives us minus 0.104 joules. So W2 is minus 0.104 joules. When a proton moves from a distance, from a point P1, which is 0.300, to point 2, which is 0.1020, the work done on the proton will be W3, which is equal to 4 times 0.3 cube minus 4 times 0.1 cube. This gives us 0.104 joules. So W3 is 0.104 joules. Part D, by calculating the total work from part B and C, we can get total work will be equal to W2 plus W3. That is equal to minus 0.104 plus 0.104. This gives us a 0. Since the total work done on a proton is 0, when the initial point and the final point are same, therefore this force is conservative force. Since we know the work done by the conservative force equals to negative of the change in potential, that is W is equal to minus del U, that is x naught minus U x naught, then we can write change in potential will be, so our change in potential x naught minus Ux will be integral from x naught to x minus 12x squared dx. This is 4x naught 3 minus 4x3. From the initial condition, U0 is equal to 0, where Ux will be 4x3. So the potential energy at any point x will be given by U is equal to minus 4x3.